Good morning. This is the Daily Space for today, Friday, September 18th, 2020. I am your host, Beth Johnson, and I am here to put planetary science in your brain. We have spent a lot of time talking about Venus this week. It's been like that meme where the guy is looking over his shoulder at a woman who is not the one next to him. So I will give my one thought on the Venus news. I think it's very interesting, and I look forward to further research as it happens. Life on Venus, but I'm no longer thinking it's incredibly unlikely. And with that, let's look at the rest of the planetary news from this week. Planetary science, in my opinion, includes exoplanets. After all, we've gone from, look, there's an exoplanet, to the exoplanet has an atmosphere with water vapor in less than 30 years. Exoplanets are no longer theoretical. We've discovered thousands of them, and their systems are incredibly diverse, leading us to change our theories about planetary system formation. So it's newsworthy when something out of the ordinary is found. In the case of our first story, a team led by Caleb Canius of Penn State has announced in the Astronomical Journal the discovery of the fifth Jupiter-sized planet orbiting a low-mass star. As Dr. Pamela says, you find something once, that's interesting. You find something twice, you have a group. Now we found this type of system 5 times. However, there is still a first here. The planet, TOI 1899b, has the longest orbital period of the warm Jupiters found, about 29 days. The other 4 examples all orbit their host stars in less than 4 days. The new planet was found using data from NASA's TESS spacecraft. The planet's mass, radius, and orbital period were determined using the Habitable Zone Planet Finder at McDonald Observatory, and its existence may answer some questions about planetary formation. As co-author Rebecca Dawson states, warm Jupiters like TOI 1899b orbit surprisingly close to their star. Even though the planet's orbital period is long compared to many other giant planets detected and characterized through the transit method, it still places the giant planet much closer to its star than we'd expect from classical formation theories. Detailed characterization of their physical and orbital properties, system architecture, and host stars, as the HPF team has done for TOI 1899b, allow us to test theories for how giant planets can form or be displaced so close to their star. Personally, I think there are so many different examples of planets and host stars and systems that I'm not certain we will ever find one unifying set of rules. As it is, we continue to learn new things about our own solar system that change our ideas of how it evolved over time. In our next story, observations taken using the Herschel Space Observatory have given us the answer to the question, what are Uranus's moons made of? A question it should be noted the research team wasn't even trying to answer. As co-author Ulrich Kloss explains, actually, we carried out the observations to measure the influence of very bright infrared sources such as Uranus on the camera detector. We discovered the moons only by chance as additional nodes in the planet's extremely bright signal. Cold objects, such as Uranus and the 5 moons included in this study, radiate very brightly in the infrared spectrum between 70 and 120 micrometers. They can reach blazingly hot, bitterly cold temperatures around negative 213 to 193 degrees Celsius. Add in the weirdness that is Uranus's extremely tilted orbit, and researchers had perfect positions to see how the surfaces of the moons retained heat as they rotated. The team found that the moons stored heat well and cooled down slowly. The conclusion was that the moons are similar in composition to dwarf planets at the edge of our solar system like Pluto or Haumea. They show characteristics like that of trans-Neptunian objects, which are located in a zone beyond the planet Neptune. Scientist Thomas Mueller noted, this would also fit with the speculations about the origin of the irregular moons. Because of their chaotic orbits, it is assumed that they were captured by the Uranian system only at a later date. I'm not going to say the result is a surprise. We've suspected that the outer planets have a lot of captured moons. But suspicion isn't the same as confirmation, and it's nice to see science telling us we were right. I'm still in favor of a Cassini-like mission to Mars, or to Uranus. There is more to learn there. Of course, missions these days have been heavily focused on sticking closer to home. Mars. We're all about Mars. Mars is the girlfriend in that meme I spoke of earlier. Now, a study from researchers at Cornell and Spain's Centro de Astrobiología using simulations involving clays and amino acids has given us pessimistic results. The study found that acidic fluids, like those that once flowed on Mars's surface, may have destroyed evidence for life hidden within the iron-rich clays of the red planet. Here's what we are hoping. The clays on Mars, like on Earth, are organized into layers. Within those layers, again, like on Earth, is where the evidence for biological life can become trapped and well preserved. These markers can include lipids and proteins and such. I'm not a biologist or a paleontologist, so I won't mess up the details. The issue is that acidic fluids can destroy this biological evidence. The researchers tried to preserve an amino acid called glycine within a clay. The clay had already been exposed to those acidic fluids. Then they exposed the clay with its preserved glycine to ultraviolet radiation similar to that of Mars and found a gel-like silica afterward. Co-author Alberto G. Ferren summarized, when clays are exposed to acidic fluids, the layers collapse and the organic matter can't be preserved. They are destroyed. Our results in this paper explain why searching for organic compounds on Mars is so sorely difficult. Not the greatest news story to end the day with, I know. So here's a final image to cheer you all up. We all know the Hubble Space Telescope takes amazing pictures of objects outside our solar system and even the Milky Way. Today, we present one taken of objects within the solar system, Jupiter and its moon Europa. In this image, we can see a storm stretched out across the mid-northern latitudes. The dark clumps trailing that storm could become another great red spot, but for the upper hemisphere. Speaking of the great red spot, underneath it is a storm we call Red Spot Junior. Junior had appeared to be fading in previous photos, but now it is darkened again and could be strengthening. And there, off to the side, is wonderful Europa, one of my personal favorite targets for life. We'll visit you soon, pretty one, soon. And that rounds out the news for today. This has been The Daily Space.